integrated circuit is called a microprocessor. Or I can even show you a figure which you have been watching since from your school. This figure. This is where you can see where the microprocessor is. Fine. There were three, four sections in this figure. One section is what? The input device section. All right. This one. This section is what we call in this the middle box. What we used to call this in the school time. What we used to call CPU.
CPU.
Yeah. Right. All that was wrong. And next we have the output section, and the fourth one is the memory unit. Alright, so these are the four blocks we have seen since in the school. Alright, so just think of something. CPU is something which is centrally located and which is meant to process. Fine. Only the new thing is there is a microprocessor which contains CPU inside it. Alright, so CPU is contained inside a microprocessor. What it can do? The microprocessor contains ALU, which is part of CPU. It contains control unit, which is again part of CPU. It contains a register array, which is part of CPU. So microprocessor is simply a chip which contains the CPU. Fine. And sometimes we call these things on chip CPU, and sometimes we call these things SOC. SOC stands for system on chip. There is a system developed on a chip. A full computer system is being developed on the chip. All right. So let's go a little further. Is this diagram having a clarity, or do I need to teach you again about this? That this is how the input device sends a signal. The signal where it goes inside the ALU. ALU processes. Then it goes through the control unit. Then it stores in the register array by the help of memory unit if it is needed in between. And finally, puts on the display in the form of an output device. Do I need to go through that again? Yes or no? Quick.
No, sir.
All right, good part. But I need to have a little interaction with few things like I want you to tell me about the input devices we know. Let me check the knowledge part. So one by one, start speaking about the input devices quick. How many input devices we know? Then we talk about the output devices. Quick, quick. So first input device.
Mouse.
Okay. Anyone else can also join in giving the answer.
Keyboard.
Keyboard,
Keyboard.
Keyboard.
Very good. Next
monitor,
is
Joystick.
no, 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 no.
Joystick.
Wait, wait, wait. Someone said monitor. Monitor is not an input device. Okay. Yes, joystick.
Printer.
Printer is not input.
So
Sir,
scanner.
microphone.
Wait, wait, wait. Microphone is great, but someone just said scanner. Scanner, is it input device?
Yes, sir.
How? Scanner input device थोड़ा सा confusion है, because scanner is something which converts a page which is in analog and it converts it into a software. It's more of a converter. Is this input device? Scanner, tell me. Scanner input device होगा. Just like mouse gives us input, keyboard gives us constant inputs. Scanner से constant inputs लेते हो आप? Microphone when it connects, it provides you constant input. Joystick again, but when scanner is connected, even it's on. It's more of a converter. All right. Okay. Anything else?
sir, webcam,
Definitely. Anything else?
Touch pen.
Sorry.
Touch pen.
Okay, okay. Touch pen. Yes, touch screen भी तो input हुआ.
बट कंप्यूटर के उसमें बात कर रहा हूँ.
हाँ हाँ. It is fine. Touch pen, or sometimes we also call this thing light pen. The way I'm writing on this screen, my pen is called BT pen, Bluetooth pen. Fine. And touch screens also, now the mobiles are having touch screens. They're also kind of a input phenomena. You touch on it and you select a device. It's more of like a cursor click from the mouse. All right. Anything else?
रिमोट.
Yeah, remote can also work definitely. Although remotes are obsolete now, but it was a input device for this. Yes. Anything else? Seems like we have covered most. Anyways, so let's talk about the output devices. How many output devices we know? Very simple. First one,
Projector.
projector. Okay.
Printer,
Oh, printer. Good.
मॉनिटर.
Speaker.
Monitor. Wait, wait. The monitor has a few classifications, right? Monitors like LED monitors, LCD monitors, and then monitors also, projectors also comes under the monitor stuff. All right. And the next one is someone said something.
Sir, headphones.
Speaker, yes, speakers and headphones. Definitely, speaker and headphone, they all are output devices. Anything else? Anything else? Finished? Chalo, no problem. Slowly, slowly, we'll add on to the stuff. So one thing still left. There is a third block we are having of memory. So how many types of memory are we having?
So primary and secondary.
Okay, you talk in that way. Primary, secondary. So again, primary is of how many types? Primary memory is of how many types?
Sir, RAM.
RAM, volatile, non-volatile वाला कुछ नहीं है. And secondary?
Sir, hard disk.
Okay. Okay, you understand in the RAM ROM term, so let's take it. Primary is RAM, secondary is ROM. RAM means randomly access memory, and ROM is read only memory, right? So let's go further. What are the classifications of RAM? How many types of RAM are there? अभी CSA की क्लास में किसी ने बोला सर 4 टाइप्स. मैंने कहा कौन से? DDR1, DDR2, DDR3, DDR4. अब बताओ इसमें और उसमें क्या डिफरेंस है? व्हाट इज DDR?
सर वोलेटाइल एंड नॉन वोलेटाइल टाइप्स
रैम
ऑफ
के
रैम.
अंदर, रैम के अंदर,
नहीं सर, मेमोरी के अंदर.
मेमोरी के अंदर बोलते हैं नॉर्मल. चलो वो तो पीछे रह गया, आप रैम में आ जाओ. चलो नेक्स्ट इज रैम्स आर ऑफ बेसिकली 2 टाइप्स, SRAM and DRAM. SRAM stands for static
Static.
RAM and D stands for dynamic.
Dynamic.
Good. And ROM are of how many types? PROM, EPROM,
EROM.
EROM कुछ नहीं होता. E square PROM and flash, and flash के बाद एक और है SSD. Okay. So चलो इसकी क्लासिफिकेशन बहुत लंबा हो जाएगा. Let's move further to the next topic. So this is all about the structure. We know about the block diagram of the CPU involving the microprocessor. Fine. Okay, so inside this central box where microprocessor is connected, the first unit what we are having is, which is the first unit, which first block, which is ALU, arithmetic and logic unit. Fine. So as far as we know, ALU is responsible for all the arithmetic as well as logical operations on the data received from input device or the memory device. Fine. So can someone tell me the ALU as it is written can perform two kind of operations. One is called arithmetic operation, other operation is called logical operation. Fine. So which operations comes under the category of arithmetic? Quick. Which operations do we call arithmetic operations?
Sir, addition, subtraction, division, multiplication.
Addition, subtraction, multiplication, division. All right. Okay. And under the logical category?
And or
And/or.
And or
nor NAND
no,
gates.
no. See, there are differences. There are few gates which are called basic gates. Then we have called logical gates. Then there are universal gates. So सिर्फ logical gate के बारे में सोचना है, ना इनके बारे में सोचना है, ना इनके बारे में सोचना है. So and or not. ठीक है, and sometimes XOR. Okay, so these are the arithmetic operations as well as the logical operations. Are we sure the anything not left in the arithmetic? Arithmetic के सारे operations complete हो गए और कोई नहीं बचा. Addition,
Modulo.
subtraction, multiplication. No. Modulo is an operator. I'm talking about the operation, beta. Just keep in mind. Modulus is an operator. Anything left? Okay, we'll see to it later. No problem. Okay, so we have seen few basic things. Let's start with the evolution of microprocessor. And if you see in your assignment, the first question of your assignment is the same. You have to write a note or a detailed description about the evolution of microprocessor. Evolution means from where it started. Fine. So it started in 1971-72 when the first processor, which was known as Intel 4004, which was a 4-bit processor. It was designed and it was introduced by the company named Intel in the year 1971-72. Fine. The team leader, who was the team leader of this? Ted Hawk. इस नाम को याद रखना. I used to ask because this man is the reason why you are studying this subject. He started inventing the microprocessor since from 1970s. Okay, so 4004 was the first one which was introduced in 1971. So after 4004, Ted Hoff and his team, they didn't stop. They started experiment towards the more useful or more expensive type of processors, so that they shouldn't stop in their research. Fine. So after that, it was first generation of the processor. So they keep on working. They keep on working. So in in 4004, what they inhibited, or if I give you a little decoding of this 4004, aren't you finding it strange that a processor was named by the numbers? इसमें कुछ कुछ ऐसा नहीं लग रहा कि why 4004? Is this a secret code or is it telling us something? कोई बताएगा 4004 का डिकोडिंग क्या हो सकती है? वाई 4004? बनाने वाले ने यही नाम क्यों रखा?
So maybe because there is 4-bit processor.
Definitely, it is a 4-bit processor. Definitely, I do not deny. Fine, but let's check out. There are two fours in this, first and last. All right. So the first four says it is a 4-bit processor, definitely. And how many operations it can do? It was designed for the four operations. So first four and last four, they all having some meaning. Okay, so you can see the operations that we have in the 4004 was addition, subtraction, boolean or, and boolean and. Okay, so these were the four operation. How many bits? Number of bits, 4. So that's why they put it in a again 4 digits, you can say, for nothing nothing 4, something like this. They wrote it and it clicks to someone that okay, this sounds good. Fine, but yes, definitely it is very good for this particular thing. But once we move further to the second generation, like 1973 onwards, when Intel started working on the second generation processors, which were 8-bit processors. Fine, the 8-bit processor, those starts from 8 alphabet. Oh, sorry, the numeric 8. Fine, and what was the first? Which was the first? 8008 was the first processor, which was launched in somewhere in the late 1980s, I guess, 1976 or 78 somewhere. Fine, same thing we have here. What 808 is? 8008 is another improved version of, sorry, after 8008, next one was 8088. Fine, so once you launch a product in the market, like Intel, once they launch in the market, they take survey feedbacks about the product. When these feedbacks are very good for the R&D, when someone tells the designers that this particular component is having this kind of problem, so designers redesign their circuit, they do implementation, they do research on that, they try to remove that error or lacunas in the circuit, so they improve it by the suggestions by the industry, and they created a new version which is called 8088. Fine, and they both were 8-bit processor. A little change in the architecture. 8008 and 8088 are having little change in the architecture, but almost same with the improved one in the second generation. So after that, there was a third generation when Intel moved from 8-bit to 16-bit. So in this 16-bit microprocessor, later in the 1978, there was a processor named 8086. This is from where we will start the study. 8086 microprocessor. So they launched it and it was very successful in the market. So there were many companies which were following the growth of Intel and the team of Ted Hoff very closely. So parallelly, there was a company which was having a name Zilog. They launched the same 8086 kind of architecture by a different name, which was Zilog Z8000. Sometimes you might find in the book Z80. So Z80 and Zilog Z800, they both are same. And one more 16-bit microprocessor was 80286. Fine. So since from this 1978 and 8086 onwards, the 16-bit microprocessors came in the market. Fine. So what benefit they gave us? So they were more of like a mini computer. They were like having all the capabilities of a computer. Only they were very small in the size. They were using those transistors, ICs concept. So that were very small in the size and they can do a lot of things in a very small space. So after this third generation, there is this fourth generation of processors, which definitely comprises of 32-bit. 32-bit means now the processor is a bigger one. It can handle more data, and it can process a lots of stuff. Fine. So the first process and the most popular one was the Intel 80386, which was the first microprocessor. Fine. After that, in the fifth generation, they moved from 32 to 64-bit processors 1995 onwards, and which was the first processor? 80586 was the first processor designed by the Intel. But you will find it very surprising that they didn't launch it in the market by the name of 80586. They launched it by the name of Pentium. And what was the actual name? Pentium Pro. Fine. So since from that Pentium Pro, Pentium 1, Pentium 2, Pentium 3, 4, they came into the market. So what was the benefit we having here in the 64-bit microprocessor? The main benefit we were having was to achieve the multi-processing. We can do a lot of processes by the same CPU, which allow multiple CPUs to be embedded in a single system. Fine. After that, there were many 64-bit processors which were in the lines like Celeron, dual core, quad core, octa core, and many. Now we know a lot about them. Fine. So this was a little brief introduction about the evolution of the microprocessor in the terms of the generations. Fine. So here we'll talk about basic terminologies or the basic terms we use in the microprocessors. They are very easy for, and you have to go through it once because since they may feel like a new to you. So let's start with them. Instruction set. Now what we have to understand is each and every microprocessor, if you talk about 8086, if you talk about 8085, they're having their own language. If 8085 speaks English, 8086 speaks like Spanish. It is something like this. If I have to study 8085, I have to study what is English. If I have to study 8086, I have to study Spanish. Fine. So all the codes will be in the respective language. That means I need to study that language. See, so that language in this processing domain is called instruction set, where all the instructions are defined of that particular processor. It is called instruction set. That means the group of commands listed for a particular processor is called. Okay, and instruction set will be different for each and every processor. Once you change the processor, it means like a new book you are studying. Okay, they may not be having the same. No, there will not be any same instruction. There will be difference. All right. So bus is a set of conductors intended to transmit the data, address control to the different elements of processor. Basically, buses are of three types: data bus, address bus, and control bus. Fine. IPC instructions per cycle. How many instructions a CPU is capable of executing in the single clock? This is called IPC, a measure. Right. Clock speed. It is a number of operations per second. Number of operations per second the processor can perform. This is the speed of your clock. Sometimes it is mentioned in megahertz, sometimes it is mentioned in gigahertz. So sometimes you might have observed the system having 2.2 gigahertz, 3.7, 3.3 gigahertz. Now they are having turbo boost. Fine, and now gamers are also using this overclocking the system. There are many. So just this means by increasing this clock speed, they can actually increase the speed of operation. Next is the bandwidth of the processor. The bandwidth of the processor means the number of bits which can be processed in a single instruction. Number of bits can be processed in the single instruction is called bandwidth of a processor. Fine. Next is called word length. Now word length, before I go with the word length, the definition is very easy to understand, but it's very good to be applicable somewhere. So I talked a lot about the generation of processors, evolution of processors. I was talking about since from 4-bit, 8-bit, 16-bit, 32-bit, 64-bit, and somewhere in future we'll talk about again about 128 bits. What are these? So if I put a single alphabet to signify all of them, let's say n bit. Fine. So this n represents all 4, 8, 16, 24, 32, 64, whatever it is. So what this n is actually, or by looking at this n, what comes in your mind? To what this is actually? If a processor is 32-bit, what 32 is? If a processor is of 64-bit, then what this is? Anyone, please? Anyone? Am I still audible?
Yes, sir.
Or is it a very tough question to answer?
So
Think.
number of ones and zeros,
Number of ones and zeros in what?
binary, मतलब तो जैसे मतलब 8 बिट होगा तो
आप एक
8,
हाँ हाँ
जैसे एक वन होगा, एक वन सर एक बिट स्पेस लेगा इस टाइप से, और एक जीरो एक बिट और लेगा।
हाँ हाँ। नहीं, मेरे को ये बताओ, एन को आप कैसे डिफाइन करोगे? व्हाट इज एन? Madhuri, you are having a little problem with the connection. Wait for some time. Anyone else want to try? What could be n? N को आप क्या बोलोगे? You have already purchased your laptop, your desktop, even your mobile phones these days. Fine, they proudly call this is a 16-bit processor, this is a 32-bit processor, this is a 64-bit processor, but that is a number. Number inside a processing unit does what? इस नंबर से हमें पता क्या चलता है? Hmm? Anyone having anything to say? Come on, talk to me. Don't worry about this. I'm not taking a
Sir,
test.
amount of data it can process.
Amount of data, it can process any amount of data. It can process 1 million bytes. A processor can process 1 million bytes. So 1 million bytes can't be the value of this n, na? What particularly is this n is? Because technical definition is very
सर
yeah, sure.
सर सर एक कंप्यूटर यूजेस एक टाइप का फिक्स नंबर का पीस ऑफ डेटा को वो फिक्स करता है। लाइक अगर हम 3 बाइट का मेमोरी लोकेशन होल्ड करवाते हैं तो वो 8
Uh-huh.
बाइनरी पैटर्न्स में करता है। लाइक 0 0 0 0 0 1 दिस काइंड ऑफ
Okay,
थिंग
okay.
इट्स लाइक एन
I
राइट
know, I,
शायद।
I know, I know you know about the bits and bytes, but where you studied hold and karta hai? Have you studied it somewhere or just assuming it as a hota hai? I don't know who was speaking. Sanchita, I guess, right?
यस सर।
करता है नहीं करता है, just leave it that part. ऐसा कुछ नहीं होता कि सिस्टम जो कुछ ऐसी चीज करता है जो हमें नहीं पता है. No, we created the system. Now we know everything about it. Don't go in the assumptions. ऐसा करता है, ऐसा नहीं होता है. I want कि ऐसा होता है. It is inside there. Fine. So okay, let's talk about it. So this n if I talk to in your terms, is the amount of data a processor can eat in a single byte uh, or in a single grasp, because bits and bytes will be again confusing. In a single grasp, getting my point? In a single grasp. तो एक बार में वो जितना डेटा खा सकता है ना, that value is defined by n. And how do we call it technically? We call this thing the word length of the processor. Fine. So let's find it more numerically. So suppose there is this 8-bit processor. Okay, but the actual size of your data is 64-bit. But how much it can eat at one time is 8-bit. So for eating 8-bit, it will take, let's say, 1 second. But this is the data what we are having is 64. So 8 will take how many seconds? This has to be
8 seconds.
multiplied by 8, and the answer is 8 seconds. The same amount of data I'm loading in a 64-bit processor. Fine. How much time it will take?
1
It
second.
will take 1 second. This is the difference you need to understand thus. Simple. Fine. So this is the word length, the number of bits the processor can process at a time is called the word length. Fine. 8-bit processor can process 8-bit data at a time. The range of word length is right now it is from 4 to 64. ठीक है, तो इतना समझो कि एक बार में वो जितना एक बाइट में खा सकता है ना, दैट इज द वर्ड लेंथ. एंड ये क्वेश्चन पूछा जाता कई बार वाया में कि 8-bit प्रोसेसर है तो मतलब क्या हुआ 8-bit का. ठीक है, एंड समटाइम्स इट इज ऑल्सो से द डेटा बस of the respective microprocessor, the data of the bus of the microprocessor is equal to n. ठीक है, तो इफ आई से 4-bit 8-bit 16 32 64, इसका मतलब ये भी है कि द डेटा बस ऑफ दैट पर्टिकुलर प्रोसेसर उस साइज की होगी. 16-bit प्रोसेसर है तो 16-bit डेटा बस, 64-bit प्रोसेसर है तो 64-bit की डेटा बस होगी. दिस इज द रूल. ठीक है, तभी तो वो डेटा एकदम से उस पर लोड करेगा और वो एकदम से उसके अंदर ट्रांसफर हो जाएगा. अगर 64-bit का डेटा आप वर्ड लेंथ है और 32-bit की डेटा बस है तो वो 2 बार में जाएगा, टाइम ज्यादा लगेगा, तो कॉन्सेप्ट फेल हो गया. ओके, इज दैट क्लियर? एन बिट
Yes,
ऑल
sir.
ऑफ यू अभी समझे? एन बिट क्या होता है? दिस इज कॉल्ड वर्ड लेंथ ऑफ प्रोसेसर. ओके, नेक्स्ट यू नो डेटा टाइप्स. There are 4-bit type of data types we have in assembly: binary, ASCII values, signed and unsigned numbers. Okay, so next we have actual your salient features of microprocessor, but since we are already running short of time, we'll cover this thing in the next class. And